Hey, sixth graders. There we go. Nice and big. In this video, I'm going to go through your class instructions for Monday, talk about what you're going to work on here when I'm not here at class today. One of those things will be notes, and so we'll go through those here in a moment as well. But your three things today are some notes on metamorphic rocks. Number 2 is a short ed puzzle going through all 3 classes of rock, since we're now about to finish the last one. And then third is to work on that 3D organizer or that flip chart that we started on Friday. Okay. If you were not here, and I think it's only kids in 6th period that were not here Friday, I have flip charts made for you. So just ask the substitute. I have them up there with your names on. Okay, we'll get to that in a second. Let's go right to notes though. So if you need, let's pause the video so that you have a chance to go open up your class notes for rocks to get to where you need to be, and then come on back to the video. Okay, let's go ahead and start. Important to start here. 2nd period class. You've done this slide that I'm starting with. You've already copied this down on Friday, so you can skip through to get to the second slide about metamorphic rocks, and there's 2 different subgroups of metamorphic rocks. If you are in 4th or 6th period class, you need to start right here. Don't skip ahead. You don't have this slide. So we're going to start right here. 2nd period, go ahead. You can fast forward to the 2nd slide. All right. Metamorphic rocks is your new subheading. So if you don't have that in, please put that in. And metamorphic rocks are formed by heat and pressure changing existing rocks. When you think about the 3 classes of rock, it's good to think about what is needed for each of the rocks to form. So for igneous rock, you know that we need lava or magma. For sedimentary rock, you know that we need sediments before sedimentary rock can form. For metamorphic rock, the key is that existing rock, okay, this part right here. That existing rock has to be there first. So metamorphic rocks come from pre-existing rocks, rocks that were already there. So that should make you think right away, well, obviously a metamorphic rock couldn't have been the first type of rock that was ever on our planet because other rocks had to be there first. And I think we talked about that it was igneous rocks when the earth was being formed and it all melted at a certain point, right? When that melting cooled, that magma and lava cooled, that's what formed the first rocks. Any rock that is buried deep within the earth can change into a metamorphic rock. It can be a sedimentary rock. It can be an igneous rock. It can even be a previous existing metamorphic rock that gets changed into a new metamorphic rock. So it could be any rock. And it also has to be buried deep within the earth, like deep, like mantle-ish layer of the earth, because it needs a tremendous amount of heat and pressure to actually take the rock and change it into a new one. It's going to like rearrange the minerals and all of these things. And for that to happen, we're talking about immense amounts of pressure. In fact, sometimes we can even see, and I'll show you on some of my examples when I'm back, you can actually see like bends and folds and curves in the rocks because of all this heat and pressure. We're talking about heat and pressure that we can only find deep within the earth. We can't recreate this above the surface. It's just too much heat and pressure. We need all that weight from all of the layers in the rock above to create that pressure. We just can't redo that here. The word metamorphic actually makes perfect sense of why they call it this, right? Comes from the Greek words meta, meaning change, morphosis, meaning form, change form. And that's what a metamorphic rock does, right? It changes from one rock to another. Okay, pause it if you need to. I'm going to move on to slide number 2. Okay, slide 2. This is where 2nd period needs to be. Okay, so 2nd period, you need to be here too. Subheading is still the same. It's still under metamorphic rocks. We're going to talk about the two subgroups. First one is called foliated metamorphic rocks. All right, so if you think about our subgroups, we had two subgroups for igneous rock, intrusive and extrusive, based off of where that melted material cooled. For sedimentary rock, we had three subgroups: clastic, organic, and chemical. And those were based off of the type of sediment that made up that sedimentary rock. The last class of rock here, metamorphic rocks, has two subgroups: foliated and non-foliated. Pretty simple to remember. So a foliated metamorphic rock has its mineral crystals actually align during heat and pressure. When the rock is going through this change because of the immense heat and pressure, the minerals that made up that previous existing rock literally get rearranged. The crystal structure gets rearranged to make this new rock. And it usually creates a huge clue that we have a foliated metamorphic rock. And that's where you see banding, like stripes. Because literally the minerals are going to line up in straight rows. Now, sometimes those rows might curve because of that pressure that has literally bent the rock and those minerals, but you see them all line up. And so you see layers, or we call this banding when you see the different mineral colors, or some of the more compact foliated metamorphic rocks, meaning like they're smushed and really skinny because of all that pressure. You might see actual layers that look like you could break off and cleave. Non-foliated metamorphic rocks are the opposite. The mineral crystals do not align. They don't line up during heat and pressure. You just kind of get this random pattern that ends up showing. Why does this happen? Well, it depends mostly on some of the minerals that made up the pre-existing rock. And we'll talk a little bit more about that when we get to our examples, because I think it makes more sense when I show you the examples and I talk about how we can actually have clues of what the pre-existing rock was before it turned into that metamorphic rock. So foliated rocks have these bands or layers in them. Non-foliated wouldn't. They have no banding. They do not have layers. If they have crystals, it's a random pattern. So scientists would call that a mosaic crystal pattern. But we do not see banding. We do not see layers. Okay. Pause the video if you need to finish typing, because now I'm going to go through and just explain the last two activities for you. Okay. Now that we're done with class notes, two more things for you to work on today. First is a short ed puzzle. It is less than 4 minutes, so it should not take too long. It is for grade, so take your time. Always remember that you have that replay button or that rewind button if you need to rewind and listen before, if you didn't catch the answer, right? After you see the question, you can always hit that rewind button. When you're done with the ed puzzle, in your science binders, you guys saved your 3D graphic organizer or your flip charts from Friday, and you have two options of what you can work on today. You can either work on some of the cover art, or if you want to start putting in some of the information, you can. We have everything you need for igneous and sedimentary, and we have kind of the start here for metamorphic. Up to you what you want to work on. If you decide to work on the cover art, okay, I have some colored pencils and markers and crayons in the back that you can use. And then up front, I have my brand new colored pencil container. And they are super neat and super organized and nice and sharp. So if you use those, we're going to keep those up here, okay? So that the substitute teacher can make sure that you are not messing those up, okay? Be a good citizen and help me if you come up there and to put some away and something is not in place. Help me out. Keep those nice and organized for me. I want them to look like Mr. Smith's, okay? All right. Those organizers are not due tomorrow or anything like that. So when class is over, you should be putting those back into your binders. Do not take them home to work on them yet. Okay, we're going to work on them a couple times in class this week, and then if you still need time, you can take them home. Okay. All right, make sure you are staying on task, that you are getting your work done. That's the expectation. And then I will be back in class tomorrow. Have a good day. See ya.